So yesterday we started simplifying square roots, okay? We went through this whole page right here, but let's continue working with simplifying square roots. So in your notebooks, I would copy down this square root of 4x to the fourth. And yesterday in our notes, we learned that when you're multiplying inside a square root, you could actually split the square root to each of the terms. So inside the square root, we have 4 times x to the fourth, which means that we're able to split the root as the square root of 4 and then the square root of x to the fourth. Now this works out beautifully because we know that the square root of 4 is what?
2.
2. And how about the square root of x to the fourth? Yesterday we learned that the square root is really the power of 1/2. So that x to the fourth is in there. And we know that a power to a power is multiplication. And 4 times half, that's like saying 4 divided by 2. So you're going to end up with x squared and with the 2 in front. So the answer is 2x squared. Okay. Now, the reality is, if you're taking a quiz or test, once you get good at this, you're going to look at this problem and you're just going to know that the answer is 2x squared. Because you're going to think, okay, the square root of 4 is 2, and the square root of x to the fourth, that's like dividing by 2, so that'd be x squared. So 2x squared is the answer. Any questions there? So once again, from yesterday, we had this this page right here yesterday. Whoops. From yesterday, we remember, or we taught you, I taught you, what am I saying? That x to any even power is easy. You just divide it by 2, right? So from yesterday, the square root of x to the 20th, that's just x to the 10th. The square root of x to the 8th, that's just x to the 4th. You guys remember that from yesterday? Yeah. And if you didn't have an even power, like if I said the square root of x to the 9th, you don't have an even power, so you're going to rewrite it with multiplication to get an even power. So you're going to rewrite x to the 9th as x to the 8th times 1 more x. And then you could split the root, and then you could actually do the square root of x to the 8th, which is x to the 4th, and the square root of x, that just comes down, square root of x. Okay, we did that yesterday. We're going to continue practicing that right now. Let's check out the next question. Go ahead and copy that down, please. And again, when you have the square root of something times something else, you could split the root. So we're going to do exactly that. We're going to say the square root of 8 and the square root of x to the 16th. So you're going to put the 8 right there and the x to the 16th right there. Okay. Now, what is the square root of 8? If you don't know, you could use a calculator, type it in, get the answer. And the answer will be 2 square root of 2. I just did that in my head. If you don't have a perfect square number, you want to rewrite it with multiplication to get a perfect square number. So that would be 4 times 2. That way, when you split the root, you could do the square root of 4 now. That will be the nice number 2, and the square root of 2 comes down. Now, what about the square root of x to the 16th? That's an even power. It's really easy. What's the answer going to be? X to the 8th, right? X to the 8th. We don't have to show our work anymore. I mean, you should know that the square root's really the power of 1/2, and 16 times half, power to a power, 16 times half is 8, okay? But what do we have here? We really have the number 2 times the square root 2 times x to the 8th. So we're going to rearrange it to make it look nicer. So we're going to say 2x to the 8th and then square root of 2 at the end. So there's your correct organized answer for this radical expression. Any questions? Let's move on. So this next one, we have the square root of 36x to the 9th. What do I do? You have 36 times x to the 9th. What do I do with the square root? Split them, right? Split them to each term that you're multiplying on the inside. So you're going to have the square root of 36 and the square root of x to the 9th. Well, the square root of 36, that's easy. What's that? 6, okay. And how about the square root of x to the 9th? I wish this were an even power, but it's not. So what am I going to do?
You're going to make it to an 8.
You're going to make it x to the 8th times 1 more x, because that's really x to the 9th. And once you do x to the 8th times 1 more x, then you could split it and actually do the square root of x to the 8th, which is what? X to the 4th. And what about the square root of x? You just bring that down, so you have the square root of x. And that's your answer, 6x to the 4th square root of x. So let's get rid of these guys and move on to number 4. Write that down, square root of 50 times x to the 25th. Square root of 50 x to the 25th. So what am I going to do? What am I going to do? Split the root, right? So you're going to say the square root of 50 and the square root of x to the 25th. It's like simplifying two separate problems, and then you worry about organizing it at the end. So square root of 50, you could do it on the calculator, or you could think 50 is not a perfect square number. I want to rewrite it with multiplication to get a perfect square number. 5 times 10 would be pointless because 5 is not a perfect square, 10 is not a perfect square. But 25 times 2, that would be great because 25 is a perfect square number. So you could actually do the square root of 25. What is the square root of 25? 5. What's the square root of 2? It stays the square root of 2. Now, what about this x to the 25th, the square root of x to the 25th? I wish it were even, so I'm going to rewrite this x to the 25th as what? X to the 24. So we're going to write x to the 24 times one more x. That way it does stay the same as x to the 25th. But I'm going to be able to now split the root, and I could actually do the square root of x to the 24th. What do I get? X to the 12th. And what about the square root of x? That just comes down. So what do I really have here? I have 5 times the square root of 2 times x to the 12th times the square root of x. Because it's all pure multiplication, we could rearrange it to make it look nice. Let's put the 5 first, the variable next, and then I'm going to actually take both square roots, and instead of splitting the roots, I'm going to put them back together. So these are split. I'm going to put them back together and multiply the 2 times x, which would give me 2x. So I have the square root of 2x. So here's my final answer, 5x to the 12th, square root of 2x. We will be seeing questions like this on the next assessment that we have. Let's take a look at number 5. Especially these. First thing to do is to separate that square root, split it. Put a square root on the 32, put a square root on the x to the 16th, put a square root on y to the 9th, put a square root on z to the 20th. So here we go, 32, x to the 16th, y to the 9th, z to the 20th. We're going to put square roots on each of those, splitting that root. And you could do this on a calculator. I'm going to do it by hand. It's not a perfect square number. I'm going to rewrite it with multiplication to get a perfect square number. I could say 4 times 8, but it's better to use the highest perfect square number, which would be what? 16. That's right, 16 times 2. So split that root. The square root of 16 is 4. Square root of 2 comes down. So far, we have 4 square root of 2. Is this easy to do? Heck yes. What is the square root of x to the 16th?
X to the 8th.
X to the 8th. All right. And this one is not an even number. I mean, this is easy because 16 divided by 2 is 8. This is a 9. I would like an even number. What could I do?
You have to make it an 8.
I could make it an 8 by rewriting it as y to the 8th times y to the 1. And then I could split the roots. And then I could actually do the square root of y to the 8. What is the square root of y to the 8?
4.
Y to the 4. And what about that square root of y to the 1? That's just the square root of y to the 1, which I'm just going to write it as the square root of y. Okay? And then what about this square root of 20, or z to the 20th? What's the answer there? Z to the 10. Because after all, the square root's really the power of 1/2, and a power to a power you multiply. 20 times half is 10. So for the answer of the square root of 32, we got this. For the answer of the square root of x to the 16th, we got this. For the answer of the square root of y to the 9th, we got this. For the answer of square root of z to the 20th, we got this. All of those answers are multiplied together. So we're just going to rearrange them to make it look as nice as possible. We're going to put the nice number first, the 4, and then we're going to move on to our regular variables, x to the 8th, y to the 4th, and z to the 10th. And at the very end, we're going to combine this square root with that square root and put them together underneath one square root. So that's going to be the square root of 2y. So that's your final simplified answer. The calculator could only really do this. But all of this other stuff you're going to have to be able to do on paper, okay? Radicals are similar to variables when it comes to adding, subtracting, or multiplying. So in Algebra 1, when we combine like terms, what's 2x plus 3x? 5x. Simple, right? Combine like terms. X's with x's, y's with y's, numbers with numbers. Now, in Algebra 2 with radicals, same concept. You have 2 of these square roots of 5 plus 3 more of these square roots of 5. What's your total? What's your final answer? 5 of those square roots of 5s. It's kind of like x's, right? Make sense? In Algebra 1, if you did not have the same identical terms, 2x to the third plus 3x to the second, could you add them in Algebra 1? No, you cannot. They're not like terms. So that would stay the same, 2x to the third plus 3x to the second. You cannot combine terms that are not alike. Likewise, right here with square roots, you cannot add 2 of these square roots of 5 with 3 of these different square roots of 7. You can't do that. So you would just leave it the same. Okay, 2 square root of 5 plus 3 square root of 7. Okay, let's do one more. In Algebra 1, you could multiply anything, right? 2x to the third times 3x to the second. What's that answer in Algebra 1? 6x to the fifth. Okay? In Algebra 2, right here with radicals, we could multiply anything. So again, right here, you really have a 2 times the square root of 5 times 3 times the square root of 7. So rearrange it, 2 times 3, and then the square root of 5 times the square root of 7. So 2 times 3 is 6, and the square root of 35 is what you would have right there. I believe that the Casio calculator could actually do this. You could type this in and it will give you 6 square root of 35. Of course, you're supposed to try to simplify the square root of 35. If you try that on the calculator, it'll just tell you square root of 35. So yeah, this would be your final simplified answer. Now, if this would have been like 40, then you could break it down to 4 times 10 and, simplify further. Anyway, if I asked you to add a number with a radical, you wouldn't be able to do that. They're not like terms, so you would leave it exactly the way it is, right? You wouldn't mess with it. But if I ask you to add 3 of these guys plus 1 more of these guys, what's my answer going to be?
3 square roots of 4?
You have 3 of these guys, and you have 1 of these guys.
4
of those guys.
Oh.
All right. It's kind of like a variable,
Yes.
like an A or like a B or like an X. But you have like terms here. You got 3, imagine x's plus 1 more x. So that'd be a total of 4 of those x's. But instead of x's, you got square roots of 2.
Yep.
Okay. Right here, could I add these guys? I have 5 of these guys and 1 of these guys. I cannot add them as is. Why not? Because they're not like terms. But you could simplify the square root of 8 and rewrite it as 4 times 2, split the root. That way you'll get 2 square root of 2. And now you could add 5 square roots of 2 plus 2 square roots of 2. That'd be a total of 7 square roots of 2. Now, if you're thinking, wait a minute, that's kind of difficult, don't worry about it. I think the calculator does that for you, right? But if you have variables involved, it won't. Okay, how about multiplying? What's square root of 2 times square root of 8?
Square root of 16?
Square root of 16. What is square root of 16?
4.
4. There you go. Okay. So all of these, the calculator will do for you. Let's do number 3. 3 is a good one. What's square root of 7 times square root of 7?
49.
The square root of 49. But what's square root of 49?
7.
7. Okay. So I want you to look at it from a different angle. If I say the square root of 7 times square root of 7, that's really saying this guy multiplied with itself 2 times, right? So that could be like writing it as an exponent. And right here, you have the square root to the power of 2. The square root and the power of 2 undoes itself. So your answer is just 7, right? So here's a big fact that when you multiply a square root with itself, the square root disappears. So if I say, what is the square root of 8 times the square root of 8? Yeah, you could say the square root of 8 times square root of 8 is square root of 64, which takes you back to 8, but the answer is just 8. What's the square root of 3 times square root of 3? Just 3. What's the square root of 7 times square root of 7? Just 7. Do you get it? Whenever you multiply a square root with itself, the square root disappears. Yes or no?
Easy.
Easy. What if I say the square root of 12 times the square root of 12?
That's 12.
That's just 12. Just the square root disappears. Simple. And we're also going to be distributing with radicals, which the calculator could do, I think. I'm not too sure. But if you take the square root of 2 times 3, just remember that this is kind of like an x. X times 3 would be 3x. In this case, you'd have 3 of those square roots of 2. Square root of 2 times negative 4, square root of 5. You have like an invisible 1 in front of there. So you're going to multiply 1 times minus 4. That's going to be a minus 4. And then you have the square root of 2 times the square root of 5. You could actually multiply those together, and that would be the square root of 10. So that would be your final answer there, distributing the square root of 2. Let's try this last one. Number 2. It's a binomial times a binomial. Let's distribute. So 3 times 4, that's 12. 3 times 3 square root of 5, that's like saying 3 times 3x. What would 3 times 3x be? It'd be 9x. What would be in this case? 9 of those square roots of 5, right? And then distribute negative 2 square root of 2 times 4. Imagine like a negative 2x times 4, that'd be a negative 8x. But in this case, it's going to be what? Negative 8 of those square roots of 2. Yay?
Yes, sir.
And then negative 2 square root of 2 times 3 square root of 5. That'd be negative 6 of those square roots of 2 times 5. You could actually multiply them together, right? Okay. And there's nothing to combine. That would be your final answer. That's nasty. I don't know if the calculator does that. But anyway, actually, we have one more here. This is a fun one. We're going to distribute 3 times 3, 9. 3 times square root of 2, what's that?
3 square roots of 2.
3 square roots of 2. How about negative square root of 2 times 3? What's that?
Negative 3.
Negative 3 square roots of 2. How about negative square root of 2 times positive square root of 2? Negative
Square roots of 2.
square root of
4.
4, which is going to ultimately just be a 2, right? What happens with these middle terms?
Cancel out.
They cancel out. So I really have 9 minus square root of 4 is 2. 9 minus 2 is 7. Beautiful. This is not a coincidence, ladies and gentlemen. When you have a binomial times the same binomial, but the only difference is that the second term has different signs, the middle terms cancel out and it ends up being beautiful. Okay? This is called multiplying a binomial by its conjugate. And we'll get more into that definition tomorrow, but right now I'm just giving you a little taste. Whenever you multiply, like even if it had a letter like 3 minus x times 3 plus x, the middle terms will cancel out and you get nice answers. Let's go to the back side of our worksheet, please, where we have the notes on imaginary numbers. Notes on imaginary numbers. Okay, so on the top left corner it says, what is the square root? Why does the square root of 9 equal 3? Because the square root is really saying what number times itself gives you that answer, right? So why is the square root of 9 equal to 3? Because 3 squared equals 9. But what if I asked you, what's the square root of negative 9? Then it's not 3, it's not negative 3, there's no real number. So this is what we need to learn. As a matter of fact, let's just go to the side over here, or go to your notebook, and let's write this down, that the square root of negative 1, that equals I. It's imaginary, okay? It's not real, it's imaginary. The square root of negative 1 is I. So if I asked you, what's the square root of negative 25, if you wanted to show your work, you would say, okay, well, I'm going to rewrite it as negative 1 times 25, and then I could split the root, and then I'll get I square root of 25. And square root of 25 is 5, so you'd have I times 5, and I times 5 is just 5I. Now, don't worry, you don't have to show all this work. It's as easy as this. Anytime you have a negative, that negative comes out as an I, and then worry about doing the square root of 25.
Oh,
Okay, so it's as simple as this. What is the square root of negative 9? 3I. What's the square root of negative 36?
6.
6I, right? Pretty simple, right? Okay. again, where does I come from? It comes from the square root of negative 1. Negative 1 is the variable I.
What if it's...
Great question. What if you have the square root of negative 24? Well, you know that, you could show your work and do everything that I did here, but you could just pull out this minus sign, and it's going to be an I out here. So you're going to have I times the square root of regular 24, and the square root of regular 24 you could do on a calculator. The calculator can't do negative 24, but it could do a regular 24.
So you can move it like outside.
You move the negative, it becomes I on the outside, and from there it would be 4 times 6 if I wanted to show my work, and you'd have 2 square root of 6, but the I comes down, so you have I times 2, that would be a 2I with the square root of 6 at the very end, so that would be your simplified answer.
Okay.
So if you understand that, you're going to love this next part. Okay, in your notebooks, please write down the fact that the square root of negative 1 is I, if you haven't written that down already. Very important stuff. Okay, so I'm going to start this pattern for you by saying that I is the square root of negative 1, okay? I is really, I'm just going to say I equals I, and I know you're going to be like, what the heck? Why is he doing I equals I? Okay, but what is I squared? What is I squared? I squared is really I times I, and we know that I is the square root of negative 1, so instead of I times I, I'm going to rewrite it as the square root of negative 1 times the square root of negative 1. And that really implies that you have the square root of negative 1 to the second power, and we know that the square root and the power of 2 undoes itself, which gives you the answer negative 1. What?
So it's just I again?
So it's negative 1.
Wait.
Whoa. Check it out. I squared is really I times I, right? But what is I? I is really the square root of negative 1. So instead of I have the square root of negative 1. Instead of I have the square root of negative. So I really have, instead of I times I have the square root of negative 1 times the square root of negative 1. And that, multiplying 2 square roots together, it's like having it squared.
Yeah.
And the square and the square root eliminate, so you just have the negative 1 left over. But you don't have to worry about that math at all. All you need to worry about is this big fact right here. I squared equals negative 1. Okay? I squared equals negative 1. Let's move on to I to the third. You're going to love it. I to the third. You see, I to the third, I could rewrite that as I squared times 1 more I. But what is I squared? What is I squared?
Negative 1.
It's negative 1. So I could rewrite this as negative 1
Times square root of negative 1.
times an I. Let's just keep it as I. And what is negative 1 times I? Negative I. Hold on. We haven't even gotten to the good part yet. We haven't got, look, good part. I to the fourth. I to the fourth, if you know that I squared is negative 1, then I to the fourth is really I squared times I squared. But what is I squared really? Negative 1. So you really have negative 1 times negative 1.
Which is 1.
Yeah. Which is 1.
Nah, that's easy.
Okay?
They're all easy.
So what you really need to know, I would say, is memorize this guy. I squared is negative 1. And also memorize this guy, that I to the fourth is positive 1. Okay? But you could actually reason through it the way I did. Okay? Now, what if I went to I to the fifth? It's getting more fun now.
Yes, sir.
I to the fifth is really I to the fourth times 1 more I. But what the heck is I to the fourth really?
That's easy. That was just...
Be 1 times negative 1.
So it'd be 1 times I, right? If, let me highlight it here. If I to the fourth is 1, then we could put a 1 right here, and it'll be 1 times I, which takes you back to I.
Yo! Okay, yeah.
Okay, so, and that's where the cycle starts over. What do I mean by cycle? This right here. If you have this down, everything else becomes easy, okay? I is I, obviously. I squared is really negative 1. I to the third is really negative I. I to the fourth is really positive 1. And then after that, it repeats. So I to the fifth would be I. I to the sixth would be I squared, which would be negative 1. I to the seventh, and so on and so on. It would repeat. Now, this guy is really important. I to the fourth is 1, because anything that's divisible, any power that's divisible by 4, like check this out. If I said, what is I to the eighth? Well, I could rewrite that as I to the fourth times I to the fourth. But we know that I to the fourth is really 1. So that's really a 1 times 1, which is 1. What is I to the 40th power, guys?
I to the 40th power.
1.
That's 1. Simple. Because if you took I to the 40th, that's I times I times I times I times I 40 times, and you started grouping them in 4, it would be a bunch of 1 times 1 times 1 times 1, and the whole answer would be 1. Because the power of 40 is actually divisible by 4, which means you'd be able to group them all in groups of 4, and there would be no i's left over.
Yep.
However, if I said, what's I to the 41? Well, then you got to think, well, that's going to be a regular I.
Yeah.
Because 41, it's not divisible by 4, but if you did divide 41 by 4, you would get 10, and you would have a remainder of 1. So that remainder of 1 is just 1 extra I, so that would be your answer, I. Make sense?
Yeah. So what we have, because no matter what, it's always going to be one of those 4.
It's always going to be one of those 4 answers when it comes just to I. So if I said, what is I? Give me any number you want. Doesn't matter.
100.
50.
100. Okay. I to the 100. First of all, is 100 divisible by 4?
Yes, sir.
Yes, it is, right?
25.
Yeah, 25. So I'd be able to group all those 100 I's, I'd be able to group them into 4, and I'd have 25 of those groups of 4 I's together, which means that the whole answer is what? 1.
Just 1.
Because if it's divisible by 4,
1.
I to the fourth is 1. Okay? But what if I had I to the 102? Well, then you'd have 102 divided by 4. That would go in 20 times. You'd have a remainder of 2. So you're really only dealing with those remainder of 2 i's. I times I is I squared, which is negative 1. Yeah, so you guys are right. Getting it? Okay. No. So we should all know that I equals I squared equals what? Negative 1. I to the third equals what? Negative 1 times I, so negative I. And then I to the fourth? Just 1. Okay, so if you know this, you can do anything. Okay? I would always just divide it by 4 and see how many i's are left over. Then you could figure out what your answer is going to be. Okay, so what's I to the fifth again? That's just I. What's I to the eighth? 1, because it's divisible by 4. What's I to the sixth? Well, you can't divide by 4. If you did divide by 4, you have a remainder of 2. That's I to the second. What's I to the second?
Just negative 1.
Negative 1. I to the 10th, is 10 divisible by 4? No, but if you did 10 divided by 4, you have 2 times. You have a remainder of 2. So what's your answer? Negative 1 again.
Sir.
I to the 41, is it divisible by 4?
Yep.
No. But
You gotta do it to 10.
you have an extra I left over.
I.
So just I is your answer.
Yes, sir.
Anyway, going back and reviewing square roots. When you have a square root and you square it, it undoes itself, right? The square and the square root, they disappear. So your answer is just 5. Okay. What's the square root of negative 1? We all said that was,
I.
that was I. What about this guy? Well, the square root and the square undo themselves. So yeah, negative 1 is your answer. How about this guy right here? What's the answer to that?
8.
8.
Negative.
Negative 8? What do we say about the square root of negative 1?
Oh, yeah. It becomes an I.
It becomes an I. So you have the square root of 64. What's the square root of 64? 8. 8 times I? 8I.
Man.
Okay? And solving, we're going to be applying square roots when we solve. And whenever you apply a square root, you have to put a plus or minus in front of your answer. So you want to get x by itself, you're going to square root, you're going to have x equals plus or minus. That negative comes out as an I, and then you have the square root of 75 to deal with. You could do that on a calculator, or you could do it by hand. Break it down to get a perfect square number. 25 times 3 is 75. Split the root. You're going to have 5 square root of 3. Of course, the calculator will do that for you. But you still have an I that comes down, and you have I times 5 times the square root of 3. So you're going to organize it as best you can. X equals plus or minus 5I, radical at the very end, square root of 3 at the end. There's your answer. Number 2. What do I do to solve? I want to get x by itself. How do you get rid of something? You do the opposite. Yeah, get rid of that minus 7 by doing plus 7. Plus 7 cancels out. 3x squared equals, what is that?
Negative 20, I don't know.
Negative 20, I don't know, 6? No. No, it's not 6. 25. 4. 4.
These are always the hardest ones.
And then we get rid of the multiplication of 3 by dividing by 3. Dividing by 3. We have x squared equals negative 8. How do I get rid of the square?
Square root.
Square root. What I do to one side, do to the other. But when you use the square root, you have to put a plus or minus in front of your answer.
Yes, sir.
What do I do with this minus? Comes out as an I. And then you could deal with the square root of 8 on the side, on the calculator. Or you could do 4 and 2. Split the 4. You get 2 square root of 2. So you really have I times 2 square root of 2. And that would just be 2I and then the square root of 2 with the plus or minus in front with the x equals.
Sir.
Fun stuff. Plus 4 cancels out. Negative 2x squared equals 26. Get rid of the multiplication of negative 2 by dividing by negative 2. You end up with x squared equals negative 13. How do I get rid of the square?
Square root.
With the square root, what you do to one side, do to the other. You're going to have x equals. Don't forget the plus or minus right in front of it.
Sure.
What happens with that?
That turns into an I.
Comes out to an I. And the square root of 13, if you do it on the calculator, it'll be the square root of 13. You can't simplify it. So there's your answer. Boom. Finding the roots, same concept. You solve it and you apply square root. When you apply square root, put a plus or minus in front of your answer. We're going to skip that for now. It's the same stuff as before. Let's move on to the last section here, complex numbers. A complex number is written in standard form. It's a plus bi. The a part is the real part. The b is the imaginary part. Okay? So operations with complex numbers, operations with i's is the same as operations in math with x's or a's or b's. It's the same thing. The only difference is if you end up with I squared, what is I squared? Negative 1. So whenever you have an I squared in your answer or in your work, you have to replace it with a negative 1. Okay? So for example, right here, what is 3i times 2i? What is 3 times 2? 6. What's I times I? I squared. So that's your answer, but what do we know about I squared? I squared is really what?
Negative 1.
This is really a negative 1. So you really have a 6 times a negative 1. So what's your final answer?
Negative 6.
Negative 6.
Yes, sir.
What about 3i plus 2i? That's 5i. You don't have to worry about changing anything because it's not an I squared. What about distributing? No problem. Okay. 3 times 4, 12. 3 times 2i?
That's 6.
6i. And that's it. And it is in order. The real part first. Whoops. The real part first, the imaginary part second. How about number 4? Let's distribute negative 3i times negative 5. What's that?
Positive 15i.
Okay. And how about negative 3i times positive 2i? Negative 6i squared. Now, that I squared needs to change to what?
Negative 1.
To a negative 1. So I really have 15i minus 6 times negative 1. And then doing the math here, I'm going to have 15i, what?
Negative 6.
Plus 6.
Yeah.
And the final detail is put your real part first. and your imaginary part second.
Estaría mal si en el quiz lo ponemos a la...
Yeah, I need you to put it in order, the real part first and the imaginary part second. Number 5, what do I do? Distribute that minus sign, that's a minus 3. Distribute that, that's a minus 5i. There's nothing to distribute over here, so you could just rewrite it without parentheses. 4 plus 2i. And now it's just a question of combining like terms. Since you want your real part first, start with the real 4 with the real minus 3. 4 minus 3 is 1. And then you could do the imaginary positive 2 minus 5. What's a positive 2 and a minus 5? Negative 3 of those i's. And that's it. It's just like x's. The only difference is if you ever have an I squared, you have to replace it with the negative 1. Check this out. We're going to distribute 1 times 3, that's 3. 1 times 4i, that's 4i. 2i times 3, what's that?
6i.
6i. And how about 2i times 4i?
8i squared.
Plus 8i squared. What about those middle terms?
You can match them.
You can match them. You could add them up. So we get 10i, positive 10i. That first term's a 3. What about this last one? I really have 8 times what?
I squared.
Yeah, you have
Oh, yeah.
8 times negative 1 because I squared is really a negative 1. So 8 times negative 1, that's a negative 8. And out of those 3 terms, I could still combine the 3 with the minus 8, and my real part will be negative 5
plus 10i.
plus 10i, the imaginary part. Woo! Oh, that's so fun. I love it. Oh, I'm going crazy. Yes. Last one here. Notice you have a binomial by its conjugate. That means that this is going to be beautiful. Check it out. 3 times 3, 9. 3 times negative 2i, what do I get? Negative 6i. How about positive 2i times 3?
Just 6i.
Positive 6i. And how about positive 2i times negative 2i?
The same thing as the other side.
Negative 4i
Oh, yeah.
squared. What happens with the middle terms? Cancel.
Yep.
What is I squared?
Negative 1.
So you really have a negative 4 times a negative 1.
That's 4.
So that's really just 4, a positive 4. And what about the 9? The 9's right there. So final answer is 13.
A nice 13.
A very beautiful 13. Whenever you multiply a binomial by its conjugate, whether it's with square roots or with imaginary values, it becomes nice and beautiful.